Many people these days do not really understand what science means and what researchers really do. What is truth? What is knowledge?
The noise, there is an overwhelming noise in every room, so...
I can never be sure that the postulate I make will not change another day. You need fundamental research, and you need that fundamental research is connected to deeper views on reality.
Our project is addressing whether or not knowledge is power, so knowing whether or not we can use information as a source of energy.
Information seems like an abstract concept to many people, but when you think of it, information needs to be stored somewhere physically. So either being in your neurons in your brain, or on paper when you write something, and the letters encode some information.
The idea is to study experimentally, mostly, new kinds of engines. So in the microscopic world, we have motor engines, for instance, that allow cars to move and stuff. And here the game is to build very small engines that live in the quantum realm and that operate with sources of energy that are very different from the source of energy that we have in the microscopic world.
How to isolate something from the rest of the universe is a bit complex, of course. So for instance, we use typical kinds of metals which are superconductors that transport electricity for free, essentially, so without any heat dissipation. We put these circuits in a closed box so that no light can go to it. We cool it down very close to the absolute zero, which is about minus 273.15 degrees Celsius, and we put it in vacuum. And we also do magnetic shielding. So all that put together, we managed to get these objects isolated for a few tens of microseconds, and which is enough for us. This is the time interval in which we can identify the quantum properties.
We are going to use the power of quantum measurement. We are basically going to use the fact that when you look at a microscopic object or at a quantum object, you change the state of the system, and therefore you can potentially provide energy to it. So that's really a new kind of field that is based on what is called the measurement back action, and this is what we want to do.
The quantum of heat, which is a new quantity that Alexia Auffèves, who is part of the project, invented and developed.
We discussed a lot with Benjamin about if we should call it quantum heat or something else. It became a joke at some point because it was a concept that was kind of difficult to really establish properly in the community, and this is actually still the source of debates because measurement does stuff to systems, and depending on how you interpret the quantum measurement and depending on your favorite interpretation, this will influence how you build the concepts, the thermodynamic concepts, to describe the effect of quantum measurement on systems.
We started thinking about this theme of quantum thermodynamics with Alexia almost 10 years ago, actually.
I have a very long-term collaboration with Ben. We've thought about experiment together for a while, and I've made models for him. This is always a great pleasure to interact with him and his team. So I'm very happy of this starting project. Very, very happy.
It takes time, but luckily for us, each step of on the way is very interesting because we learn, we have fun with fabricating devices, measuring samples, doing machine shop work, and there are many interesting aspects to this kind of projects.
We are living in times where the typical timescales of public entities is becoming shorter and shorter because of elections, because of the democratic process. The democratic process is excellent, but this has a cost because governments are less and less inclined to make long-term investments and take risks. And at the same time, companies, they want to make profit, so they also want short return on investment. And therefore, we need people who bet and take risks and don't really care if it will give a result or not. And that's what fundamental research needs. And that's why I think that FQxI is doing a great job, because it takes risks.
It's really thrilling to be able to explore questions that are puzzling, that are not answered anywhere, and to be able to bring a solution and to see what nature imposes on us on this as a result of this question. So it's really exciting.
Fundamental research is not a matter of roadmaps. It's a matter of passion. It's a matter of building a consistent vision on the world, and it's more like working like an artist. You must be inspired. Doubt is not something that tells that we don't know what we are doing. Absolutely not. We learn to do with the doubt, which is actually the human fate. We don't know everything. So that's science.